Welcome to the Explainer. Today, we are diving deep into one of the most common hurdles in any aptitude test, area questions. We're going to break it all down, build it back up, and hopefully turn this tricky topic into one of your biggest strengths.
I totally get it. You see a weird, complex shape, a jumble of numbers, and you can just feel the pressure mounting. For a lot of people, these kinds of questions are a huge source of anxiety. But you know what? They really don't have to be. By the end of this explainer, you'll have the tools, the strategy, and the confidence to look at any area question and know exactly where to start. We are going to make this your secret weapon.
Okay, so every great skill starts with a solid foundation. And for area questions, that foundation is your formula toolkit. Let's lock in the non-negotiables, the stuff you absolutely have to know cold.
First things first, what even is area? Well, simply put, it's just the amount of flat space a shape takes up. You can think of it as how many tiny one-by-one squares it would take to tile the entire surface. And that's exactly why we measure it in square units. The rectangle is our starting point. You know this one, a classic four-sided figure where opposite sides are equal. The area is as simple as it gets. Just multiply the length by the breadth. That's it. Easy. And a square? Well, that's just a special, more perfect rectangle where all four sides are the same length. So instead of length times breadth, it's just side times side, or what we call a squared. Oh, and here's a pro tip for your toolkit. You can also find its area using the formula 1/2 times the diagonal squared. Tuck that one away, it comes in super handy. Next up, the circle. Its area formula introduces the famous pi, which, for most tests, you can just think of as 22/7. All you need is the radius, that's the distance from the center to the edge, and the formula does the rest, pi times the radius squared. And this image shows the area of a triangle perfectly. A good way to think of a triangle is that it's basically half of a rectangle, and that's why its area is just 1/2 of its base multiplied by its height. Just remember, it has to be the perpendicular height. That's key.
So, we have the formulas, but knowing them is one thing. Actually using them when the clock is ticking is a whole other ballgame. So let's put our new toolkit into action with a real exam-style problem. All right, here's a pretty typical question. We need to find the area of a circle, and they've told us its diameter is 42 centimeters. Did you spot the little trick here? The formula needs the radius, but they gave us the diameter. But don't panic, we just need a clear plan. Step 1, get the radius from the diameter. Step 2, plug that radius into our pi r squared formula. And step 3, calculate the final answer. See? It's that simple. Let's walk through it together.
So, following our plan, the radius is just half of 42, which is 21. We plug that into the formula, we get 22/7 times 21 squared, which gives us 1,386 square centimeters. See? A simple plan makes any question totally manageable. All right, time to level up. What happens when the exam throws some bizarre composite shape at you? The secret is that these are almost always just simple shapes playing dress up. Take a look at this. It's a kite. But if you look closer, it's really made of two familiar pieces, a square and a small triangle. They give us the diagonal of the square and the base and height of the triangle. So, how do we find the total area? The crucial insight here is this. Don't go looking for some complicated kite formula. No. Instead, just find the area of the square, then find the area of the triangle, and simply add them together. It's the classic divide and conquer strategy. So here's the breakdown. For the square, we're going to use that handy diagonal formula we just added to our toolkit. Its area is 1/2 times the diagonal squared. That gives us 1,152. For the triangle, it's the classic half base times height, which is 12. Now all we do is add them up. And boom, we get a total area of 1164 square centimeters. That's it, a complex-looking shape broken down into a really simple solution. Now, in a timed test, knowing the right answer isn't always enough. You've got to be fast. So let's look at a common problem type and a speed hack that will give you that winning edge. Here's the question. You have a rectangle. You chop its length in half, but you triple its breadth. What's the percentage change to its total area? So the standard way is slow. You'd say the original area is x times y, the new area is x/2 times 3y, which is 3/2 xy. Then you'd have to calculate the percentage increase. It works, for sure, but it takes precious time. Let's try the hack. Here's the shortcut, and it's a game changer. Forget the algebra and think in factors. The length is changed by a factor of 1/2. The breadth is changed by a factor of 3. To find the total change in area, you just multiply those factors. So 1/2 times 3 gives us a total change factor of 1.5. And a factor of 1.5 means the new area is 150% of the old one, which is just a 50% increase. No messy algebra, just a direct answer in seconds. That's how you save time and beat the clock. Okay, so we've covered the core formulas, we've applied them to both basic and complex shapes, and we've even learned a really cool speed hack. You've got the tools. And now I'm going to leave you with a final challenge. Take a close look at this figure. Using everything we've covered today, can you figure out the ratio of the area of the circle to the area of the square? Give it a shot, think it through, break it down, and see if you can solve it. Thanks for watching.